What if you could take all the carbon dioxide out of the burning of fossil fuels and make it clean? Would you do it? Come join me as we take a look at carbon capture. Welcome to Climate Honesty, where we simplify complex topics to help you be better informed on energy and climate. If you pay attention to climate change stuff at all, you've probably heard the term carbon capture. And as the name implies, what that means is that we're capturing carbon. And there's three basic ways we can capture carbon. We can capture it out of the flue gas or the exhaust out of a plant like a cement plant or steel manufacturing or power generation. We can take that flue gas, we can pull the carbon dioxide out of it, and then release the rest of the flue gas into the atmosphere. And then there's pre-combustion, and pre-combustion, as the name implies, is simply pulling the carbon out of the fuel going to be burned. And then there's the pulling carbon out of the atmosphere or out of the ground and storing it someplace. So those are the three types. We have pre-combustion, we have post-combustion, and we have just pulling it out of the air. So first let's talk about post-combustion carbon capture, and we'll use a natural gas power plant as an example. Now, natural gas power generation is typically done in what's called a cogeneration plant. And the way this works is that we start with a turbine. Similar to an airplane turbine where we take air in, compress it, mix it with natural gas, and burn it across a turbine. Now, coming out of that engine is hot gas. Now, we take that hot gas and we run it through a heat exchanger, which is simply tubes or pipes running through the chimney or the exhaust, the flue gas. And we use that to create steam. Then we use the steam to drop through another turbine and we get an additional power out of it. And that's called cogeneration. We can use the steam to power another process, or we can use the steam to power another turbine and increase the efficiency of the overall power generation. Coming out of the heat exchanger, we're still several hundred degrees Fahrenheit, and we need to cool that down to about 150, 100 in order to pull the CO2 out of it. So we're going to run it through what's called a flue gas cooler, where we contact the flue gas with water vapor. A flue gas cooler is simply a way that we contact the flue gas with water. So we run water into the top through something called structured packing, or a type of tray, where the water comes down and then dribbles across this structure, and the flue gas flows up through it, contacts the water, and cools down. Well, once it's cold enough, then we're going to put it into a tower or a big, tall, vertical vessel. And we're going to put it in there, and we're going to do it again. We're going to mix it, instead of with water this time, we're going to mix it with amine. So the amine is going to be dropping down through the tower. The flue gas is going to be coming up. What happens is the amine reacts with the carbon dioxide and goes into solution. And then that gets dropped out of the bottom of the tower, and what goes out of the top is the rest of the flue gas minus the CO2. And this process can be very efficient. It can be 99+% efficient, depending on how much amine we circulate, etc. So we design it to be very efficient in the high 90 percentile. Now, the flue gas coming out of the amine tower is going to be essentially free of carbon dioxide, and that's what we mean by carbon capture. Now we have this carbon dioxide in solution with the amine, and so we have to regenerate it, or pull the carbon dioxide out of the solution that we just put it into. And that takes energy. So what we can do is take some of the steam from the cogeneration plant or from the exhaust turbine, and we can use that steam to regenerate the amine and reuse the amine. So we're just circulating the amine in a big circle and reusing it, and we're pulling it, we're regenerating it and pulling the CO2 out. Now we're stuck with the CO2. The CO2 is in gas form typically, and then we have to cool it down or pressurize it and ship it via pipeline or truck or rail car. The most efficient way to transport CO2 is going to be in a pipeline, and that's true of, whether it's CO2 or natural gas or anything. Pipelines are the most efficient and the safest form of transportation. The second way we can do carbon capture is doing pre-combustion carbon capture. This means we're going to pull the carbon dioxide out of the feedstock going into the combustion process. This could be done with coal or different types of natural gas that have high concentrations of CO2. And that typically, the pre-combustion is typically cheaper per pound of CO2 removed. The third way we can do carbon capture is by actually just pulling carbon dioxide out of the air in the atmosphere. This obviously, it's very dispersed in the atmosphere. It can be done and it is being done. It's just fairly not very cost effective. And I don't see that having a huge impact on reductions in carbon dioxide in the atmosphere because it would take so much process to process all that air, and the CO2 concentration is very low. The economic way to pull CO2 out of a gas stream, whether it's just air or natural gas or some effluent or discharge from a turbine, is if the concentration of CO2 is high. So when it's higher, it's cheaper to get it out per pound. When it's low, it costs a lot more per pound of CO2 to pull it out of the gas. What do we do with the CO2 once we capture it? We can put it in a pipeline or truck it or rail it someplace where we can inject it back into the ground. Now, this is done extensively with natural gas. We inject natural gas into the ground to pressurize wells after we pull oil out of the ground. This has been done since for the last over 100 years, where we inject stuff back into the ground. That's where we came from, and we put it back in the ground in the same place where we got it. Now, CO2 wells are not as prolific as natural gas wells, obviously because people haven't been doing it, but it's simple enough to find places to put it in the ground and store it in the ground. If we raise the pressure of the CO2 up above 1,000 psi-ish, then it acts like a liquid and it stays in the ground, and there's really not a lot of risk of it coming back out of the ground. That kind of stuff is in the ground all over the place right now. And we inject natural gas into the ground at 5,000 psi and have been doing that for years. A lot of my career has been working on injection compressors that do just that. The same thing can be done with CO2. We can pressurize it to 1,000 psi, which is fairly simple, and then inject it into the ground and store it in the ground. We simply need places to store it, and it wouldn't be that hard to store all the CO2 we can capture in various formations under the ground. So the obvious question is, if carbon capture and reinjection is a completely reasonable process and it's fairly simple, why aren't we doing it now? And the reason is because it costs money. And nobody's going to spend the money if they don't have to. When we look at the future of fossil fuels, there's people that seem to think that we're just going to stop using fossil fuels in the next 10 to 20 years, and that we're just going to convert over to a different process. That is simply not going to happen. Anybody who knows anything about looking at future projections can see that we're not going to stop using fossil fuels anytime soon. We can reduce them, and we have been reducing them. However, we're going to continue to use fossil fuels. And actually, if you look at the EIA's predictions for 2050, we'll actually be using more fossil fuels in the world in 2050 than we are today. Now, I realize that's probably not what you've heard. However, if you go and dig a little deeper into the projections, sure, in the United States, we're going to be reducing carbon dioxide output, and in some of Europe, we'll be reducing, etc. But if you look at the world as a whole, the amount of fossil fuels burned is actually going to go up for a significant amount of time. Now, if we can get carbon capture to be economical, which it is fairly economical. There hasn't been a lot of carbon capture installed, so we haven't been able to really refine the process and make it more modular and easier to install. There's a lot of money in government appropriations for that. However, that's got to happen soon, and it is happening right now. In order to do carbon capture, you have to burn extra fossil fuels or extra energy in order to do the carbon capture, because it takes energy to regenerate whatever you're using to strip CO2 out of the gas. Now, that's typically in the range of 5 to 15% extra energy, which would add about 5 to 15, maybe up to as high as 20% added to the cost of the electricity generated from the fossil fuel that we're doing the carbon capture on. The same would be true if we were doing carbon capture on cement manufacturing or steel manufacturing. We would be adding an additional 5 to 20% on the cost of the fuel source or the electricity source for whatever process we're doing. The good thing about carbon capture is that carbon capture actually can help us in the industries where large amount of electricity is needed, such as cement manufacturing and steel manufacturing. Even solar cell manufacturing requires large amounts of electricity, typically generated by coal. So if we can clean up the gas coming off of that electricity generation, then that is a net benefit. That's a good thing that we can reduce carbon dioxide generated by these industries. That going to solar is simply not going to solve that problem anytime soon. Carbon capture is being installed in various locations in the United States and around the world, but in order for it to be utilized extensively to reduce the overall production of carbon dioxide from the generation of electricity or other processes, we need some type of financial incentive because it simply adds cost to electricity generation and to power generation. So there needs to be a reason why people invest in it. And if the reason is to reduce carbon emissions, then that needs to come with some type of benefit for the person doing the carbon capture. Now, the financial incentive side is kind of out of my area of interest, so we'll leave that to somebody else to figure out how to do to make carbon capture economically viable. I just wanted to show you that it is technically feasible and it's not that complicated. It can easily be done and is simply an extension of normal processes that we do every day. Like and subscribe if you enjoyed the video. Check out my channel for a deeper dive into the topics of energy and climate change.